Welcome to our video on functions and relations. Today we'll explore what makes a relation a function and learn how to determine if a given relation is a function or not. Let's start with some basic definitions. A relation is defined as a set of ordered pairs, x, y. The set of all x values is called the domain of the relation, and the set of all y values is called the range. Now, what makes a relation a function? A relation is a function if for each value of x in the domain, there is exactly one value of y in the range. Let's visualize this concept. Here we have a mapping from x values to y values. In a function, each x can only point to one y. This is a function because each x maps to exactly one y value. But this is not a function because the x value too maps to both 4 and 5. Now, let's examine some examples to determine if they represent functions. Here's our first example. We have a relation with the ordered pairs 2, 3, 2, 4, and 3, 5. Is this a function? No, it's not, because the x value 2 corresponds to two different y values, 3 and 4. In a function, each x value must map to exactly one y value. Let's look at another example. We have the ordered pairs 1, 3, 2, 3, and 3, 5. Is this a function? Yes, it is. Each x value in the domain, 1, 2, and 3, maps to exactly one y value. The x values are all different, so we don't have the same problem as in the first example. Let's look at another example in the form of a mapping diagram. Here we have a domain with elements -2, 6, and pi, all mapping to corresponding elements -2, 6, and pi in the range. Is this a function? Yes, because each domain value maps to exactly one range value. Let's look at some examples involving equations. Here's the equation y equals 2x plus 6. Is this a function? Yes, it is. For each value of x, there is exactly one value of y. For example, if x is 2, then y is 10. If x is 0, then y is 6. Each input x gives exactly one output y. Now let's talk about the vertical line test, which is a graphical method to determine if a relation is a function. If no vertical line intersects the graph of a relation in more than one point, then the relation represents a function. This is because a vertical line represents a single x value. If that line intersects the graph multiple times, it means that one x value corresponds to multiple y values, which violates the definition of a function. Let's look at some examples using the vertical line test. Example 9 shows a circle. Is this a function? No, because a vertical line will intersect the circle in 2 points, meaning one x value maps to two different y values. Example 10 shows multiple lines that do not overlap vertically. This is a function because no vertical line will intersect the graph more than once. Now, let's discuss how to find the domain and range of a function. For a function, the domain is the set of all possible input values, and the range is the set of all possible output values. Let's look at this graph of a parabola, y equals x squared. What's the domain? Since we can input any real number x into this equation, the domain is all real numbers or -infinity to +infinity. And what's the range? Since x squared is always greater than or equal to 0, the range is from 0 to +infinity. Finally, let's discuss function notation. Instead of writing y equals an expression in x, we can write f of x equals that expression. For example, if y equals 2x squared minus 3x plus 1, we can write f of x equals 2x squared minus 3x plus 1. To evaluate a function for a specific value, we substitute that value for x. For example, f of -3 means we substitute x equals -3 into the function. This gives us f of -3 equals 2 times -3 squared minus 3 times -3 plus 1, which equals 2 times 9 minus 3 times -3 plus 1, equals 18 plus 9 plus 1, equals 28. In conclusion, a relation is a function if each input value maps to exactly one output value. We can use the vertical line test to determine if a graph represents a function. The domain of a function is the set of all possible input values, and the range is the set of all possible output values. Function notation gives us a convenient way to write and evaluate functions. Thanks for watching. I hope this video helped you understand functions and relations better.